Oh, we're on 1,000,000. We're on 1,000,000 and we've got 1.5 minutes left. Let's go. This is bringing me, I think, a bit too much joy, this game. And that's why we make it a 64-bit unsigned integer. Today, we're gonna remake, completely from scratch, the very first game that I ever made. All the way back in August 2012 for the Ludum Dare 24 Game Jam. Back then, I was just learning programming, and I thought that doing a 48-hour game jam would be a good thing to get better. Was I wrong? I don't know. I think I made a pretty cool game, but I was also doing my final year of high school, so I think I only got to spend about 20 hours making it. And now, I'm really excited to take a trip down memory lane and see just how much my programming has changed over the last 12 years. So what's the game? Well, it's called Genesis. I've made a lot of videos about it in the past, so I won't talk about it here. It was written completely in Java 1.6, I think, back then. But today, we're gonna be rewriting it in C++ and using RELIB, which is a video game programming library. A library which I have never used before. However, it won the poll that I put up for what I should use for this project, and I really wanted to check it out, so thank you, poll. Now, speaking of things I've never used before, today for this project, I'm gonna be using JetBrains CLine, a C++ IDE that you guys have been asking me to try out forever. And coincidentally, JetBrains reached out, is sponsoring this video, and thus made this project here possible. So let's see how CLine works out for me. Oh, and finally, in the description below, you'll find links to the original Java source code for the game that I made 12 years ago, this C++ remake source code, as well as the actual game that you can download and play on itch.io. The version that we're remaking here, that is. Let's go. Let's remake this game. So this is RELIB, a simple and easy to use library to enjoy video games programming. And your goal is just to find the women. The idea is that this population counter that's going up, that's not representative of like actually the women here or whatever, or like I should say the general population here. I think I might have to restart. Let's just restart, because there was a woman close by, yeah, but I lost her. All right, there we go. So see, you spawn children, all of them are male, by the way, for the purposes of this experiment. You just go around finding more, and every time you reproduce like that, the rate of this population increasing goes up, right? So the rate increases. 9080 was my population. That is probably a future GPU I will buy at some point. So without further ado, let's actually open CLine. Okay, so this is on the wiki on RELIB's GitHub. They have this CMake lists over here. What this CMake file does, you can see, is it tries to find the RELIB package, but if it couldn't find it, instead of just like erroring you, it actually downloads it and sets it up for you, right? So this is great. I think I'm gonna use this. All right, so let's do C, YouTube Genesis. I'll just do Genesis CPP. We're gonna do C++ 20. It's gonna be C++ executable with CMake here. Let's do create. Yeah, this window, sure. Okay, so now we've got a brand new project basically set up. So what we're gonna do, we're gonna grab this core basic window. I'm just gonna copy the raw text from it. We're gonna add it. So we're just gonna do right click, add new C++ file. We're gonna make it a C file. And I think it was called, I wanna call it the same thing, core basic window.c. So we've got, that's it. Congrats, you created your first window. That was easy. And let's just copy the rest of this, actually all of it. And we'll just replace the code here with it, and I'll include IOStream. This used to be a .c file, now we've got a CPP file, right? So we're gonna compile it with C++ instead of C. There's a cheat sheet, which is nice because that just shows you all of the stuff that you have to work with. So I'm gonna keep this cheat sheet open. Yeah, look, let's just get started. I'm gonna obviously change this to be Genesis. Now the screen width and height, interestingly enough, the Java version actually has a fixed screen width and height. It's not resizable, but you can see that in the Java version, in the original, as I mentioned, there's a scale of 3. So the width is actually 300, but we scale it up by 3 for the window, and it's 16:10 aspect ratio. I'm gonna basically copy this, right? So we're gonna copy this, we're gonna replace screen width and height with this. Obviously final and static and whatever means nothing to us. We can keep it as static. So let's just make a C++ class. We're gonna call it application, and that's where all that stuff's gonna live, just because it's nice to have like a natural place for it. So let's just do that. All right, so this is going a little hard with this application specification. Yes, as a game engine developer, you can see I'm a little bit over engineering this, but it's okay. I forgive myself. Our first window, we now got a name called Genesis. It looks like it's the right size. So I think we're actually pretty good. We did it, guys. We've basically remade it. So what we're gonna try and do is we're gonna try and draw an image. Now, enter the cheat sheet. Here it is, update texture. Right? Update GPU texture with new data. So this is kind of what I want, right? Yeah, so this pixel array, that's where we write everything into. And you can see the screen class is like, it's just a way to basically write, like, it's just a class to organize that. Oh, that's cool. Look, it says to include RELIB. Awesome. See, that's cool. That's helpful. Nice work. So let's make a renderer. Now, the renderer that we had inside this, like, okay, so each just took in a width and height and actually created its own integer array called pixels. So I think we're gonna probably do that. We can just get it to take in a width and height, again, just going with integers here. So obviously we need to actually have a raylib image though. So let's include raylib. I'll do that up here actually. Why are some of these includes gray and some of them are, oh, does this just mean I'm not using anything from there? Oh man, that's really cool. Yes, that's awesome. That's an awesome feature. So I think it's gray because I'm not using anything from that include and somehow it knows that. So if I had if I did this, hey, it's green now. Oh, that's actually really good. That's my favorite feature so far. Rather than getting the image, we probably actually need a texture from raylib, and we can create one obviously. Yeah, because we don't really, once we've created it, I think we can just make a texture. We might not even need a member variable being an image here. I think we can probably just do texture. So let's see over here. So we have texture, we just have load texture. Texture 2D is probably what we want here. But then we also have, a load texture from image function, which gives us a texture 2D. So let's make this a texture 2D. And then let's do load image, load texture from image, and we'll just do image. And that's it. We should have a texture, and obviously we can call update texture and then give it some pixels. So we should hopefully see like a pink thing. Okay, that's not pink. Red is the most significant bits, and alpha is the least significant bits. That's a curveball. So if we wanted pink, we'd have to do, yeah, this. So this will clear the screen to some random pixels. Here, it's pretty simple. So we want to keep the alpha channel the same, obviously. That will just fill our alpha channel with FF specifically, and then we'll use that here because I want the alpha obviously to be 255. All right, sweet. Oh, this is perfect. Okay. We could work on getting sprites loaded, I guess. These are the stupid sprites I made. So what we're gonna do now is we're gonna try to actually load those images using raylib, like a load image or something. Load image is a file. Yeah, that's it, man. That's into CPU memory, which is perfect. Okay, so we're gonna load this image. So now we should have an image. And yeah, I mean, look, we just need the pixels from this image, really. So I think let's find a function here that will give us access to the pixels because there should be something like that. I think image just has the data here. So there you go. I just want to make sure that we can actually see our sprite sheet, I guess. So here's what we're going to do. Into the renderer, we're going to add a function here that's going to be I don't know, render sprite. We'll make it generic. We'll just call it render sprite sheet, and we can give it an offset if we want. And we're just gonna render the whole sheet. Render sprite sheet, let's just do 50-50 as a little offset. Yeah, so it's not loading our sprite sheet. So that's our first kind of problem so far. Stride is 4, not 3. Really? But it's RGB 8. Or is there padding? Is that why? But still, that wouldn't have made sense. We'd be off by 1, but we'd still see something, see? So I don't think that's right. No, image buffer is U132T, so we don't want to do I plus equals 3 because then we'll do every third pixel. At the moment, debugging is harder with chat because no one's saying anything correct in chat. So what happens between this? Deleting, see? So we delete it somehow. That's why. You guys were talking about this code is golden, okay? Don't question my code. This code is golden. Now, you've probably noticed that I've been using CLine for this project, a C/C++ IDE which revolves around CMake. Why? Well, I've been looking for an excuse to try it out because you guys keep recommending it. So when JetBrains reached out, it was time. So first of all, huge thank you to JetBrains for sponsoring this video. And second of all, let me tell you about JetBrains' fantastic suite of IDEs. By creating really smart, elegant, and reliable IDEs for basically every language out there. They're all based on the same platform. So once you get comfortable with one of them, you're good to go with all of them. And because they're all cross-platform, JetBrains have really created quite a nice ecosystem here. Using CLine for this project for the first time ever was honestly a joy. I mean, just watch the rest of this video to see what my experience was like. And I'm not a huge fan of CMake, but the fact that CLine actually assists you really well in writing CMake made the whole CMake experience so much more enjoyable. Between you and me, I'm actually considering maybe it's not so bad. Maybe I should use it for some things. The amount of help and suggestions that CLine was giving me as I was writing my code blew me away and would be especially helpful to those that are learning C++. So I think it's great because I'm not using anything from that include and somehow it knows that. So if I did this, hey, it's green now. Oh, that's actually really good. So if you guys have never tried JetBrains IDEs before, I highly recommend that you give them a go. Just go to my link in the description below and from there try out whichever ones interest you. Huge thank you again to JetBrains for sponsoring this video and thank you also for making some really nice IDEs. Now we've got to figure out why we're deleting it. Okay, I'm being stupid. I'm saying where could this be getting deleted without actually finding out where it's being deleted from. So let's just put a breakpoint in and see. where it's being deleted from. Because it's being deleted before I even have a chance to do anything. Render init deletes it when it reloads it here, but it got loaded with no path initially. That doesn't make any sense. How could it have loaded the image? Oh, it's move constructed. It moves it in. Yeah, I didn't delete the move constructor. Oh my gosh, that is so annoying. It's not gonna be a constructor because that's not a new object. If it was this, then it would be the move constructor, but it's actually the assignment operator. So, because it's not a constructor. So it's not a constructor for this object, it's an assignment. So I wish I didn't, see this would have been avoided if I just made it a unique pointer or something, but I wanted it to be like stack allocated for some reason. So here we are. There's no real reason to do that. I mean, it's one less memory interaction though, because this ultimately holds a heap allocated buffer. But, you know, I suffer the consequences, I guess. So sprite sheet operator equals, and then what was it? Just the same as this, right? Oh, no, it's actually const. Oh, so this isn't even the move. This is just a regular assignment operator, but it's been deleted for some reason. Because that's a copy though. So maybe I just provide a move one? Does that even make sense? Okay, do you guys think this will work now? Hey, we did it. So now, let's try and render a sprite, but we need to know what coordinate. Obviously, we need to actually set up the sprites now. So I think the ones we need, I mean, we could just copy them. I guess we can just copy them from here, can't we? To save time. Because we'll have them like all defined here. We probably won't need all of them though. And also we're gonna have to change them completely. Nice. Okay, so we've got all of them now here. I think we can just do, instead of run a sprite sheet, we'll do obviously render sprite. There'll be an X and a Y as to where, I guess, in the world we want this. We'll have to implement a camera as well. And then we'll actually take in a sprite. Renderer, the basic idea is that we'll go through Y. So yeah, so there's only gonna be like the sprite size basically, which is, we know is 16, but I'm still gonna read the variable. Then we're gonna figure out our offset in the world. So XP plus, yeah, so XO then. There's a lot of, I know there's a lot of like abbreviations here, but XO is gonna be the offset into the screen. So where on the screen would you like your sprite? YP is also where on the screen would you like your sprite, but the reason why you need the offset is because this is gonna be X plus XP, right? XO is gonna be which the individual pixel in like on the screen, whereas X is the individual pixel in local space, meaning within the sprite itself, at 0 being like the beginning of the sprite. And XP is just this coordinate. Obviously it's fixed because we're not setting it in the for loop. Let's go back to application, I think. And instead of rendering the sprite sheet, let's try and render a sprite. So sure, 50-50, and then we'll say sprites, and then what do we want? Okay, grass ground. I mean, that's also 0, 0. I mean, let's see what 0, 0 is. It might be pink. It might be, okay, it's wrong. Now that's weird though, because I didn't expect that. I think something's wrong with my code. I think what's sus is this. I don't think we can do this. Yeah, we can't do this. I think this still needs to be this actually. That I think is the issue because we haven't actually changed the width of the rows. That's probably why. Yeah, there we go. Okay. I think that worked. Oh, so good. We don't actually have to change anything. So let's try flower, for example. We'll see what we get. Okay, good. So the levels are pretty simple. The levels are just PNG files. Every single pixel that we have here is a tile, basically. And the color of the pixel just tells you which tile type to use, right? That's all it is. So all we need to do is basically loop through all of this and just determine what tile is what. We can do this either live when it's time to render. We can just look up the pixel value and then get the tile from like a map. I think I actually just had a big if statement situation going on in the Java code. We'll have a look in a minute. Yeah, so like for example, see here's my tile map. It's not actually a map or anything. It's just a bunch of if statements. And it's just comparing like if you're at a particular coordinate, whether or not that tile is this color. And if it's this color, you'll return a particular tile type. I guess we'll make an unordered map and we'll go obviously from color to sprite for now. So, well, I mean, for one, I know that that's obviously gonna be sprites grass, right? All right, cool. So we get this now. Not really what I was expecting because we should have got an ocean in that coordinate, I believe. And also this just happens to be the color of brokenness. As in like we made it return grass if it's broken. Yeah, so okay, so now I'm gonna have to have a look at whether or not these channels though are flipped. So we should have seen water, so let's try and flip these channels. So I'll put FF here and 3A here and we'll just see if we get water because then we'll know everything has to be flipped. Yes, okay, everything has to be flipped. I think I want to be able to move around the map. That's probably what I'm going to do next. Here is where I'm going to put the input stuff. So we have XA and YA, right? Both 0. So these are two little variables, which are basically just where we're trying to move 2. If we press like the, you know, key W or whatever, then we want to do YA minus minus. That's the code I got here. Let's duplicate this a few times. So we got S, we got A, we got D. When we render the level, we need to basically get the player, and we basically need the X and the Y of the player. X view and Y view, or view X and view Y. So we'll do player X minus renderer get width divided by 2. For now, maybe let's just render, let's just set sprite equal to, or m sprite equal to, oh yeah, how do we read, oh, get sprite, we implemented that. So let's set m sprite equal to sprites player 0, for example, just so that we have something to render. Hey, check this out. And we can't move at the moment. So let's fix that up. So we should be hitting player update, because I think we're updating all of our entities, and that should be doing this, and we should be moving, because this should be, let's just see if this is getting hit. Should be. Oh, it's not. So we're not updating our player. Game update's probably not being called. So inside application, we're doing game render, but I bet we're not doing game update. There's actually inside on update anyway. Okay, cool. So we can move around. So you can see that it changes to the right animation. It just doesn't play the animation because we're not flipping the sprite. And also the direction is almost correct. Going left for some reason doesn't work, like as in doesn't do the right thing. That's a bit weird. Would have thought that would have worked because it looks like I copied the original code. Oh, because going left requires sprite flip. That's why, because it uses the same sprite, but it flips it. That's why. So basically if flip is 1 or 3, we just do 15 minus X when we do this. So we go through the for loop backwards. 1 and 3 because it's a horizontal flip. And if it's, I guess, 2 or 3 here, we do, okay, right. So 0 is no flip, 1 is just on the X axis, 2 is just on the Y axis, 3 is both of them. That's why. So could have definitely had an enum or something for that. Okay, so that didn't quite work. Very interestingly. I think it did. I think it's just that when we read the sprite buffer here, we need to make sure that we also do XSYS. Because you could see the outline was correct, but like the transparency or whatever was wrong. And there we go, right? We need to create the tile system basically at this point in time. Like if it's a tree, we need to render the 4 pieces of the tree. If it's a torch, we need to render some light or whatever. If it's a rock or like a tree that we can't pass through, we need to return like that it's solid so that we collide with it. We can still have like tiles, and then we can have tile types ultimately. Right? Like we could have a tile that has a specific sprite. We could still have tile instances, I think, but just not have them be subclasses. Because this isn't too bad, I think. The worst part is that you can see each one of these is a different type. Yeah, like some of them, and here they all are. So you got like flower tile, grass tile, ice, light, rock, snow tree top, stone, tile, you know, tree tile, void tile, water tile. Like that's just too much. And a lot of them do nothing. Some of them do stuff though. Yeah, so some of them actually are animated, for example. Probably make an enum class here called tile type. So like literally, let's go back to here and let's grab all of these. So I'm gonna literally copy and paste all of these. And then we're gonna trim out most of this stuff. So at the moment level, we'll do get tile sprite, and that will get us a sprite. So instead of that, I think I wanna get us a tile. So now we're gonna change this finally from get tile sprite to get tile. So we actually don't need this tile map anymore. Like as in this tile map is now going to be a map of actual tiles rather than sprites. And same, I guess, with this. So we need to make sure we have everything else defined, which I think we actually do. Oh no, we don't. I just copied the tile types, didn't I? So now if we go into tiles, each of these types needs to basically be defined. So if I just copy this, I've already got water. All right, cool. Okay, so this is still not changing, whereas it should be. Let's have a look at why. I feel like, yeah, we're updating it. Water anim over here. Why is my water not animated, guys? Come on, what's up? I mean, it should be working. And this is definitely, oh, hold on. Well, yeah, there's only one instance of these. That's what inline means. Yeah, because what if it's like not true? Because that would make sense. It's almost behaving as if, no, that doesn't make sense. Because this should just be a global variable. And that should be like editing it directly, but it's almost behaving as if that's like some local copy or something. Well, yeah, there's water 1, there's water 2. I guess it's not clearing the buffer. I don't know why that's happening, but anyway, we're clearly alternating between the two. It's just not updating the buffer all the time. You know what it is? I know what it is. It's because the tile map has its own instance of tile. That's why. And that's fine, obviously, unless you change it. So you better change the one in the tile map instead of changing it globally like this. That's why. I mean, we could just make this be even like a reference maybe. Would that work? I just know references inside standard library is a bit weird. Okay, well that works. I could definitely have it be a pointer though. And then we could just do this. That would work fine. That's fine because it's a pointer, but references obviously have slightly different semantics. So I don't know if this is correct. Ref is fishy normally. Yeah, so I don't know. I guess I would probably do this then. Can also take a look at the math and stuff that happens here if people are interested in it. I mean, this looks pretty straightforward. This is just finding the 4 corners of the tile across like in the actual level basically. So, and XA is where we're going to move. So that's like our delta, right? So X is our current position and XA is just how much we want to move by. And that way it just checks whether or not it's viable to move into that tile basically. Yeah, so we've got a few different things we could do. Yeah, I think collision. If we wanted to, we could have a bool here called solid, you know, false by default or whatever. And then everything that we wanted to be solid, we would just have true. Yeah, so here we go. So we commented out the actual collision code that tells us whether or not we can move. So let's uncomment that. And just like that, we may have collision. Okay, that works pretty well. Yeah, look at that. Let's introduce the females. So let's go ahead and create a C++ class called female. We could just make a constructor, to be completely honest, that just takes in like the spawn position. So if the player collides with them, that's where the breeding happens. But we should just see the female hopefully walking around by itself. Hey, there it is. Okay, tag is red though, which means you can't breed. Yeah, this is a bit annoying, but if mob is instance of female and mob can spawn child, then we just did a little color switch. I think what we can do, even though it doesn't really make sense, this can spawn child. We can actually put it into mob. And the reason why is because I think that tag color of red is very specific. Oh, well, no, actually, this also has this red tag. But actually, actually though, the point is to change it to green if can spawn child is true. But can spawn child will always be false for the player and for the male children. So I need to make sure it's false basically. But for female, when we create a female, we set can spawn child to true. So that maybe should make the female green now and we should remain red. So yeah, we remain red, but the female should be green. The female is green, beautiful. Next step is the whole reproduction situation, which happens, I think, on collision with a female. So check collision with females happens here. This is the collision with the female. So let's copy this code. We have to go through all the level entities here. If they're female, okay, so we need a way to get all females. Because us getting all of the females is such a popular thing to do, maybe we can optimize for that. One thing I like doing generally when we have derived classes like this is I like to have kind of like what we did with the tiles maybe, but an enum class called entity type. And this just saves us having to use things like dynamic cast. You know, we can just have like entity none. You know, we can have like player. Forest mob is technically the name that this game uses. And then we'll have female. Yeah, so basically the idea is we get rid of a lot of this stuff. And like all we really need to do is do like level get female entities. Okay, random next int. Oh, what? That's inside the for loop. Oh, it's a bit weird. Doesn't that mean it's gonna randomly generate a number every time it checks that condition? That's a bit wild. I guess that's a bug. I don't know. So we need to make a new forest mob, and then we give it an X and a Y. The whole population growth thing we need to do. Entity can spawn child is now false. This is our female. So we need to figure out where to spawn a female. We'll get a spawn point. So X and Y, SX and SY, spawn X, spawn Y, we'll say is a spawn female. Now if I collide with the female, ready? Okay, it's because the onUpdate function ends up adding entities and then this is like, what? Like we could just make this a normal loop and that in that case it would still be dodgy, but at least it wouldn't crash. And I'm guessing that would work. It's definitely more dodgy than doing a deferred add. Okay, so there we go. And we should have spawned another female somewhere here maybe? Yep, there she is. I guess we just keep score now because we've basically got the whole game loop going, I think. Population plus equals growth, thankfully, is not dependent on frame rate. Because render runs uncapped, but update happens 60 times a second in this game. So if I copy this just directly from the Java version, which I'm about to do, then inside update, we have this, and inside render, we have this. So yeah, let's have a look at how we can render text in Rayloop, because we have not done that yet. Okay, our text. So we've got, oh, draw FPS. We should probably do that. Draw text. There you go. We've got font size. That'll be using the default font. We've got position. We've got color. Yeah, draw text. We'll just do draw text. That's funny how easy this is. Hopefully I'm not wrong. And this ends up being very tricky, but we'll see. X, Y, size are even in the same order. Style, I don't know about. It's probably bold or not, but for now we'll do that. And we'll have to load up a different font, I think. And then color will be, so they want a color. So I think we can just do get color. Color, and that's it, I think. All right. Well, I guess we can hit F5. I mean, it'll be fixed at like, I don't know what the population number is supposed to be. Okay, we didn't see a thing. We might be rendering everything else on top. Yeah, so we'll do renderer update, which we'll do that, and then we'll do draw texture. So we actually kind of need to draw the font here, I think, after we draw this texture. Yeah, cool. There it is, right? And it is actually going up by the growth rate. Let's get the timer working. So there is a timer. I don't actually know how this even works because you've only got 5 minutes to play the game. So there's actually this code here that updates once per second. So we probably need to make this happen, and it just does level update timer, and it kind of formats everything for us. So when we start the game, we need to get the current time. Does Rayleigh have any time related utilities? Get time. Yes, I guess so. Let's have a look at this. Get elapsed time measure in seconds since init timer. WW get time. Okay, cool. Yeah, that makes sense. So this is how it kind of works. We do last time, I guess, ++, and then that means that if we somehow froze for 3 seconds, it will actually shoot 3 of these in a row. I don't think we need that, but that's how this game used to work. Okay, so we're finally in update timer for level. So let's have a look at what I wrote here. Basically this, and then render timer has to render it like so. Maybe put this at the bottom of the file. So yeah, we got our timer. Seems to work pretty well. I think we would just move on to lighting now. Yeah, and the whole day-night cycle situation, right? Int brightness equals 0. And then I guess the idea is it's just brightness ++. Oh, this is so annoying, isn't it? Because it's like, if night, brightness ++ return. If day, brightness -- return. This obviously does nothing, and we shouldn't never get past these two unless it breaks. And if brightness is greater than 20, then it's day, which means what exactly? And see, this is annoying because, and we go all the way to -200. So, I mean, look, the way I would do this now is probably like, I'd probably have like some kind of brightness delta. So since brightness is neither of these and day night is neither of these, we actually do wind up here, funnily enough, for the first state. And then once we hit 20, then for the first time, one of these becomes true, which is day, and we'll keep doing none of these, and we'll keep doing the day thing, which is subtracting. That's kind of funny. So I'd start this delta at 1 basically, and then I just do plus equals delta. So we'll do that, I guess, at the end, because we'll first decide what we're doing. And change brightness just seems to do this. So it extracts all the different channels, clamps it to some amount, and then it just adds the amount we're trying to add. And I guess that's why level brightness is probably between like -200 or something and 20. We'll add these functions. I might put them at the very end, and then we can just copy them from Java, and I think that should reasonably work. So mob has a light distance, which is how far away they are from the light, and based on that we'll actually have like some attenuation going on with the light here. Let's try that. What's happening here? What is going on? Or was that just a fail? Oh, you think it's working, but it's very bright. Oh, I didn't even think of that possibility. Oh yeah, because you can see population in the corner. Huh, yeah, you're right, that's funny. Lower brightness is 2. Okay, that's not going up too much. What about the channels though? Because this had to be in a specific order. Oh, we're not providing an alpha channel anymore. I think we're losing the alpha channel. That's probably what it is. No, it seems to work. We've got day-night cycle now. I guess we work on the torches. So this is where it's a bit different because we need to obviously get the sprite sheet buffer and the sprite buffer. And then if we want the color, we have to do this in the sprite buffer. And that gives us a color. And I think we just do light tiles or something. And then you can see if we find a torch, that's where this comes in. So we literally just do that. Now we have the light tiles. And then we just have to do I'll just call render light tile. I'll just make a function here, I think, in this class that does that. And then we're gonna make that basically do this, right? So I'll copy that. And we've got the super fast day night cycle. Hey, okay, almost good. The actual torches themselves are not bright. Oh, here we go. If tile is not an instance of torch tile, change brightness. So see, they remain bright. Okay, mobs are dark though. So that's next up, I think. So mobs are supposed to have some form of light. Render lighting, it's called. And they take in a bunch of these light tiles. And I guess we can just copy this. So we should have a light distance now, which means that when we rendered the mob, code we already added for this should just work. So let's see if that works. Cool. I mean, I'm bright. Now, I think it might have the same bugs that we had. Because see, I remain bright. So we've successfully replicated the weird bug we had in Java where the mob actually stays lit. Now, is that just because the brightness, like if I go too far, the brightness doesn't update or something? The problem with this is like, what happens if I'm not within a light tile? It doesn't actually reduce my brightness. I feel like if anything, it should probably set light distance to like, not 0, but like, I guess -1 initially, and that might even fix the bug. Yeah, I mean, it's still kind of, it doesn't fade out as smoothly as I'd like, but you can see that if I'm out of the light, it actually does reset me back to 0. So that does fix that bug. Let's just make a light emission tiles for now. Then we can do update lighting with light emission tiles. You know, we've got just torch tiles here. We can just loop through them here. And then just figure out the distance between these two things. Vector2 distance is what we can just use for that from Raylib, just to make it a little bit easier. Not that it's hard to work out the distance between 2 vectors or 2 points, but we can just do Vector2 distance, for example. And then now we can do distance between player position and light position. Like that's what it actually wants me to do. So now I get darker, and if I go into the light source, I do go up in brightness. I think I want to do the main menu first. Let's make this set menu level situation happen. So I think that's going to be in game, and then like, sure, we have a menu theme. So I'm going to probably start with render. So let's just copy render. Now play help and about. So basically we have this whole situation here that I'm just probably going to copy. I don't know, let's have a look. So we should be able to cycle through the menu options and hit play, I guess, maybe. Okay, we can go through the menu options. And then if I hit enter, we play. Look at that. That should be that. So game over now. Let's have a look at how we actually lose though. So what happens, I guess that's like the timer reaching 0. So where do we actually update timer? Okay, so if timer is less than or equal to 0 and play is true, then we set play to false and we make this game over menu. 5, 4, 3, 2. I don't know why it like gives up so early. It's annoying because it does timer sec minus and then does the check. So it doesn't actually give a chance for the frame to pass. So I would do this here instead. Let's do sound, man. I've got no idea how to do that, obviously, in Raylib. It's my first time using Raylib. So let's have a look at the cheat sheet. So we can load sound and then we can just play it. So we can make a new class called sound, you know, basically all of these. So like breed, and that will just be res sound breed.wave. So we'll have just all of them kind of statically defined. So all of these, right? So I'll copy this. I mean, I could add these all to a static list and then iterate through them to stop them all, but I guess I will not do that and I will just do stop. So yeah, so we have all of these guys and you can see they're all like commented out at the moment. So now I can go through all of them and uncomment them. All right, let's see. It does say failed to load audio buffer a bunch of times, but the file exists. Failed to create buffer. Oh, right, I haven't initialized audio. Lol. So when we create the application, init window, let's do init audio device, and then in shutdown, when we do close window, I don't know if we can destroy audio device or something. Actually is close audio device. Still failed to create buffer. Okay, mini audio does look like it's correct though. It's using mini audio. Doesn't say which device it's using, which is a bit annoying. Hazel does. Turns out I was trying to load the sound before initializing the audio device. Oh, okay. So yes, technically maybe because this happens statically, remember? So we made this happen here. We could lazy load it. Like we could just be like, because I don't know if there are any prerequisites for this. We could basically just do in our first sound constructor in an audio device, like unless like we can have a look at what happens here. Yeah, so that seems to have worked. Device initialized successfully. So it's not playing our main menu music. Didn't that play it as well? The back button, and then that works. No music though. And yeah, the game over thing works. That's nice. Okay, so what's up with the music never playing? Because I'm pretty sure, I don't know if I have to do anything specific with music versus sound. Because I think it's just load music stream and then play music stream. Seems legit. Yeah, so load music stream, but then there's update music stream. So do I have to do this every frame or something? For what? For each file it's playing. It's a bit annoying, isn't it? Update music stream. Okay, let's see what happens with this. Nothing happens with this. Why is it, how's it null? Did something stop it? What? So it's playing and it's not playing here. Oh, it's inline Cherno, you buffoon. Sorry, this is the Java code. This is what I meant. This is the Java code's leaking to me because it used to be public static. And then I just changed that to inline. Maybe this is actually why everything was screwed up, but we'll see, maybe not. Okay, so now we're in here. Okay, we have music. That's good. All right, cool. Let's just test the game now because that's it. We basically made the game. Where are the women? Hey, Hey, here we go. Kind of wish this was a bit bigger because it's a bit small. Damn, I should almost start again. Can't find anyone. Okay, so how's the lighting looking? This seems to work pretty well. I'm getting brighter when I go close to the light. Oh, here's a bunch. Oh, there's a lot here, man. They're all hanging out here. The collision's like not 100% perfect, but that's kind of what makes the game harder. And the collision I completely copied and pasted from Java, so it's identical to the original game. Ah, yes, we got them in a spawn trap. Let's go. All right, let me test the lighting real quick. Yep, lighting looks perfect for all of the mobs actually. Okay, we are cooking, man. We've got 2 minutes left. We're already above 100K. Let's go. Oh, we're on 1 million. We're on 1 million and we've got 1.5 minutes left. Let's go. This is bringing me, I think, a bit too much joy, this game. But this is the thing, because this game's kind of exponential, you can get ridiculously... I don't think I'm ever going to beat this current score. Oh, man, I'm getting a lot now as well. Oh, man, look at that score. Look at that score. And that's why we make it a 64-bit unsigned integer. So we got how much here? We got 4.4 billion. We beat a UINT 32T. Let's go. Ugh, what a journey. As I mentioned in the beginning, you can download and play the game for free. It's on itch.io. The source code to both the original version and the remake version are both available as well on GitHub. I hope you guys enjoyed this video. I really enjoyed making it. I thought it was really cool to sit down and actually do a project kind of in its entirety, all on stream, especially my first game, just because that project obviously is very nostalgic and it's really the beginning of my whole programming career. And Sea Lion, well, you saw what my experience with Sea Lion was like. It's pretty good. I mean, I've yet to try it on like an actually big project like Hazel or even bigger, but for this particular small project, like it was honestly a delight to use. And I think the single best thing about it was just how like fast and fluid and responsive it was. And because all of the tools that I generally use for programming were all there, yeah, honestly, no complaints. Well done, JetBrains. And Raylib was also really good. Everything just worked and it was just amazingly simple. In fact, what I want to do with this project is to take it a little bit further, is to add support for more platforms. So Raylib also supports Mac and Linux. We're obviously using CMake through Sea Lion to build this. And in fact, the other really cool thing about Raylib is that it builds using Mscripton into JavaScript so you can run it like inside a web browser. So I would really love to get this game into a web browser because the original back in 2012 used Java applets to make that possible. So if we really want to come full circle on this, then I think we need to build it for web. And finally, we could also make this game hardware accelerated because at the moment it's just software rasterizing all the pixels, copying them like into a pixel array on the CPU, and then just rendering that as a final image. We could actually use like a graphics API to render everything, and that might be faster. I mean, that would usually be much faster, but because this game is quite low scale, I actually don't know what will end up being faster. I still think probably the GPU, but who knows? So if you guys want to see any of that, let me know in the comment section below, as well as if you'd like to see more projects like these, where I just sit down, do everything live on stream, and then turn it into a video like this. Because to be honest, I'd love to do more of these challenges in the future. Thought it was really fun, and so I hope you also enjoyed it. I'll see you guys next time. Goodbye.